Welcome to Forge College. You're currently in the Capstone Project module of our Inheritance and Interfaces in Solidity course, which is a key part of the Solidity from Zero track. Today, we are tackling module decomposition and interface mapping. In our last lesson, Project Overview and Requirements, we figured out exactly what we are going to build. Now it's time to figure out how to actually organize those requirements into an architecture that can scale up without breaking down. Imagine a busy restaurant kitchen, one frantic person trying to chop vegetables, cook steaks, wash dishes, and take orders all at once. Complete disaster. Writing smart contracts is surprisingly similar. If you dump all your logic, your accounting rules, your security checks, and your user interactions into one massive contract, you end up with an equally dangerous, tangled mess. Good engineering demands that we break complex systems down into distinct, isolated jobs. That way, no single piece of code gets overwhelmed. This brings us to module decomposition. It is the practice of breaking a large system apart into smaller, testable contracts, where each contract has exactly one clear responsibility. Let's apply this to our decentralized marketplace capstone project. Instead of building one giant marketplace contract, we need to carefully break it apart. We assign item management to a listing module, which acts like our waiter. We hand financial escrow over to a payment module, acting as our cashier, and user scores go to a separate reputation module. Doing this establishes a vital rule called data ownership. This means only one specific module can be the absolute source of truth for its designated data. Our payment module is the sole owner of the financial records. Because of this strict ownership, other modules cannot directly reach in and manipulate data that belongs to someone else. The listing module can't adjust balances in the cash register. Strictly dividing our code into these single responsibility modules prevents conflicts, reduces bugs, and ensures every component remains the absolute authority over its own domain. But this creates a practical problem. If these modules are isolated and cannot touch each other's data, how do they actually coordinate an action, like a user buying an item? Let's look back at our kitchen. The waiter doesn't cook the food. Instead, they communicate with the chef by passing a standardized order ticket. In Solidity, this order ticket is called an interface contract. It is a minimal, unchanging public promise, a thin facade that dictates exactly how outside modules are allowed to request actions. For example, when a buyer wants an item, the listing module doesn't move the money itself. It simply submits a specific command, like hold payment for this listing ID, directly to the payment module's public interface. Relying on these stable interface shapes, rather than tangled direct commands, keeps our code clean. It minimizes dependencies, so you can safely upgrade one module later without accidentally breaking the whole system. Before you spend hours writing complex code, you need a way to guarantee these new interfaces will actually handle the project's requirements correctly. To do this, we use what we call success checkpoints. Think of these as simple, preset rules that define exactly what a successful module interaction must achieve. For example, if we have a function to adjust a balance, our success checkpoint says the user's record must update accurately, and the amount can never drop below zero. Establishing these success checkpoints up front gives you a direct blueprint for the automated tests you will write later on. By defining these rules now, you save yourself from having to fix big structural mistakes once you start the heavy coding. You might be wondering why we go through the effort of creating these strict boundaries and mapping out standard interfaces in the first place. The technical payoff is a powerful concept called mockability. Because the listing module only communicates through an interface, you can test it using a fake, temporary version of the payment module. You don't have to launch complex external logic or set up entire token contracts just to verify that your single component is doing its job correctly. Mockable interfaces guarantee that your testing process remains completely isolated, incredibly fast, and very gas efficient. Let's review the 3 architectural pillars we built today. We defined authoritative data ownership, established stable interfaces for communication, and set success checkpoints to guide our logic. Your project's structural blueprint is now fully prepared for actual code implementation. In our next lesson, Implementing Core Modules, we will translate these conceptual interfaces into real Solidity code and begin writing those automated tests. This video was made by Forge College. To learn more about this subject, and explore other Web3 topics, visit us at forge.college. I'll see you in the next lesson.